Okay, so today we're going to be reviewing our notes for Lesson 2 of Unit 1, which is on subatomic particles. So the first thing we're going to discuss here is the difference between a proton, a neutron, and an electron, but more importantly, it's important that you remember that an element is the term given to things that contain a certain number of protons, neutrons, and electrons, and in case you don't remember, we will be talking about the difference between these three in a little bit. But each element can have different types of atoms that make up the element. So there are things that are called isotopes, as you'll see down here. And we will talk much more about these in the future, but they are called isotopes, something to familiarize yourself with now. And this example talks about carbon. Carbon is notorious for having multiple isotopes. So carbon is the element with atomic number 6 in the periodic table, but there are actually 3 types of carbon atoms as listed here. We have carbon 12, carbon 13, and carbon 14. Now, as you look down through here, the only thing that changes is the number of neutrons, so that all of these species of carbon have 6 protons and 6 electrons. But as you see, carbon 12 is 6 neutrons, carbon 13 is 7 neutrons, and carbon 14 is 8 neutrons. Notice that this number goes up by 1 as well when the number of neutrons go up by 1. So essentially, isotopes are atoms with the same number of protons and a different number of neutrons, but we'll talk about this more in the future. What you need to know now, though, is when we say carbon in class, we are talking about the element, not a specific atom or isotope. So that's really important. We're talking about the element, not a specific atom or isotope. Again, this will be explained more in detail later. We just want to introduce you to it now. Okay? So the number of protons determines the identity of an element. Okay? So the number of protons determines the identity of the element. The protons are the defining characteristic that tells you which element you're talking about. For example, if I say the element with number of protons is equal to 6, that's carbon, as you can see up here. But remember that this particular statement will be very important. So the number of protons determines the identity of an element. It'll be useful to us for the rest of the year in this class. So another example, if we say an element has 5 protons, we'll know it's boron regardless of the number of neutrons and electrons. Alright, so we are going to talk about what's the differences between protons, neutrons, and electrons. For our purpose, we're going to use the solar system model of the atom, which you might have seen before. It is this one that is defined here. So essentially, we have the nucleus in the middle here, and there are protons and neutrons in the nucleus, whereas the electrons are kind of on these outer rings here. This is probably the model that you've seen before. So down here, we kind of have a summary chart here. So protons, neutrons, and electrons. Protons are located in the nucleus, so are the neutrons. They have a charge that is different for each of these species. Protons have a charge of +1, neutrons have a charge of 0. They're neutral, they don't have a charge. And electrons have a -1 charge. Now the mass of these is different. We'll talk about this more, but this is kind of a measurement of mass, AMU here. So protons have a mass of 1 AMU. So do neutrons, but notice that electrons do not. Their mass is 0 AMU. So AMU refers to atomic mass units. It's just kind of a measurement of the mass of something. So when we talk about these, it's important to remember what the differences between the 3 of them, the difference in their charges, where they're located, and their mass differences. So now we're going to talk about the numbers on the periodic table. So whenever you look on the periodic table, you'll see 2 numbers. So for example, if you look at your periodic table that's in the front of your note packet here, you'll see in the box for carbon, for example, let's keep using that, it's going to look like this. So notice you have 2 numbers here. You have this one at the top, the 6, and then the 12. So if we look at the atomic number versus the mass number, the atomic number would be the smaller of the 2, so that would be the 6. That's going to indicate the number of protons, which is the identity of the element, and will also indicate the number of electrons if it's neutral. So neutral means the element has no charge. So it would make sense that you need to have the same number of plus and the same number of negative. If these will equal out, then essentially it's a 0 charge. Okay? The mass number is the larger number, so it'll indicate the average mass of the isotopes that make up that element. We're going to talk more about this later, but just know that the bigger number will be the mass number, so this is the mass number. Okay? And then what you need to know just kind of familiarize yourself with from this statement here, is as long as we tell you it's neutral, you know that the number of protons is going to equal the number of neutrons. Okay. Again, this down here just kind of explains what we talked about earlier. We'll talk about this later. But if you use the carbon example from the last page, you know that there's more than one different isotope of carbon. Okay, so finding the number of protons and electrons from the periodic table. So to find the number of protons and or electrons for an element, you would use the atomic number. We are assuming that all of these are neutral, which is why they would have the same number of protons and electrons. So we're going to go through this example here. If you look at your periodic table, that's in the beginning of your note packet. You can look for sodium. So it's going to take you a little bit of time at the beginning to find where everything is in the periodic table, but trust me, you'll be amazed as the year goes on. You'll know where things are. You'll memorize it pretty quickly just from using it all the time. All right, so for sodium, if you look at the number, the smaller of the two numbers, it's the number on top of the Na. It has 11 protons and 11 electrons. Calcium, again, the smaller number, the one on top, 20 protons, 20 electrons. Next we have copper. Copper is in the middle in the transition metal section. There's 29 protons and then 29 electrons. Nitrogen over on the right has 7 protons and 7 electrons. Iodine has 53 protons, 53 electrons. Si, silicon, that is number 14. It's atomic number 14, so it has 14 protons and 14 electrons. Iron is in the middle in the transition metal section as well, 26 of each. Aluminum is over on the right side, has 13 protons, 13 electrons. Again, you have two numbers there. You want to pick the smaller one, so that'd be 13. It's going to have 13 of each. Oxygen has 8 of each, assuming it's neutral. And argon. Argon is on the far right, 18 of each. So one thing to notice as you're looking for these in the periodic table, they're ordered in terms of increasing atomic number. So for example, if you look at the right side, it's BCN, so boron, carbon, nitrogen in that order because boron has atomic number 5, carbon has atomic number 6, nitrogen has atomic number 7, so it's just increasing. So it's an easy way to find what you're looking for in the periodic table. So moving along into lesson number 3, the structure of the periodic table. The first thing we're going to talk about is some vocabulary. So groups are going to be the columns. You might also hear them called the families, but essentially the columns in the table, so what goes up and down. Periods are the horizontal rows, so what's going left to right across there. Metals, they're left of the diagonal line, and nonmetals are right of the diagonal line. There's also known as the steps. So if you look at your periodic table, the one that we gave you in the beginning, if you can see where it gets a little darker gray as you go across, it kind of looks like this. Okay, so this is what I'll be referring to as the steps. You can also think of it as a diagonal line if you kind of would imagine that structure there. But if you look at the steps, anything on the right would be nonmetals, so this side would be nonmetals, this side would be the metals. The metalloids, which are the semimetals, are going to be right on either side of these steps. So if you look where the steps are, you can see there's Si, Ge, As, Sb, Te, Po, and At. So those are all listed here. The transition metals are the middle section of the periodic table. They're in columns 3 through 12. And the noble gases are the last column to the far right. Okay, that's most of the vocabulary you're going to need to know for this lesson here. Now we're also going to do this task together, this example, so that you guys are more familiar with identifying these different species for all the elements. So the first thing we're going to do is we're going to look for the symbol, the atomic number, the mass number, number of protons, electrons, column number, period number, and if it's a metal or a non-metal. We're going to do a couple of these together so you can make sure you're on the right track, and then you can finish the rest of these on your own. So for hydrogen, you're going to want to find hydrogen. The symbol is H. The atomic number is 1. The mass number is also 1. Hydrogen's kind of a unique situation in a lot of cases on the periodic table. There's 1 proton, 1 electron because the atomic number is 1. Hydrogen is kind of moved on the periodic table. It's most like the species in column number 1, if you think back to periodicity, and it's in the first period. Hydrogen is also a non-metal. Hydrogen's tricky to identify those things. The rest of them are more straightforward. So bromine, the symbol for bromine is Br. The atomic number for bromine is 35. Again, the smaller of the two. The mass number is 80, the larger of the two. Since the atomic number is 35, you know that the number of protons is 35 because the atomic number is the number of protons. We're assuming it's neutral, so we're going to have 35 electrons since we have 35 neutrons. Bromine is in column 7 and period 4. It is a non-metal. It's to the right of those steps. Aluminum is Al. The atomic number for aluminum is 13. 27 is the mass number. The number of protons is 13. Number of electrons is also 13. The column number is 3, and the period is 3 as well. And it is a metal to the left of those steps. So let's look at iron. Iron is Fe. The atomic number is 26, the smaller of the two numbers. The mass number, the larger of the two numbers, is 56. 26 is the number of protons, and 26 is the number of electrons. The column number is kind of tricky. It's in the transition metals. I'm just going to write down the transition metals, so Tm. I'm not too concerned about that. We can talk about that more in class. And the period number is 4. And we know that it is a metal. It's a transition metal, so it's a metal. Sulfur, well, it's the last one we'll do together, is S. The atomic number is 16. Mass number is 32. The number of protons is the same as the atomic number, so 16. Again, we're assuming it's neutral, so these two columns should always be equal. And this one is equal to the atomic number. All right, the column number for sulfur is 6, and the period is 3. And it is a non-metal. All right, so you guys can finish the last ones of these together. We can go over them in class to make sure you're on the right page. But hopefully those 5 examples helped you determine if you're on the right page or not.